Hey y'all, so today we're going to graph the remaining trig functions of tangent, cotangent, secant, and cosecant. So again, how you find the points on the graph is making your table of values by plugging in like negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0. So finding what is the tangent of those different values. So the tangent of negative pi is 0. And so you go to negative pi and you plot that point 0. Again, let's go, okay, what's the tangent of negative pi over 2? And that's undefined. So when it's undefined, that means there's an asymptote there. That means the graph isn't going to hit that line. And then, so let's look at the tangent of negative 3 pi over 4. And that's 1. So about there. And this is just kind of what the tangent graph looks like. So it goes through the origin and it has vertical asymptotes at negative pi over 2 and pi over 2. And so the period of tangent is pi, because every pi distance, you have another similar graph. So the domain is our x values, and it's all real numbers except at those asymptotes, nothing's happening. And that's at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. So every pi over 2 away is an asymptote. So the domain is all real numbers except for pi over 2 times k. The range, that is our y values, and the tangent graph goes up and down forever. So the range is all real numbers. Tangent is an odd function. And then the period is pi. Forgot to write that in. Period's pi. The x-intercept happens at pi. Right here, there's an x-intercept. And then at negative pi. So every pi away, there is an x-intercept. And then for the vertex asymptotes, so that's just saying at every pi over 2, there's a vertical asymptote. And then looking at cotangent, it's like the flipped of tangent. And so again, you can go ahead and make a table of values and then plot your points. And so the one thing we want to realize here is that the vertical asymptote is at 0 and pi. And now you flip the direction and it goes through pi over 2. And then still, same thing. It happens, same graph, every pi distance. So the properties of cotangent are domain is all real numbers, except now our asymptotes are at pi. So every pi away, so pi times k. And then the range, again, this graph goes up and down forever. So all real numbers. It's an odd function. The period is pi. The x-intercept, so there's one at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. So that means every pi over 2 in distance, there is an x-intercept. And then the vertex asymptote, that happens at pi. There's one at 0. There's one at negative pi. So every pi distance, there is a vertical asymptote. So that's just what all the stuff on the right means. Okay. So now to draw cosecant and secant. So when you're drawing cosecant, you can draw the function in terms of sine. Because as we know, cosecant is the reciprocal function of sine. So you go ahead and you draw the sine function like normal. And then at those humps, you just draw the curves. So the curves are the cosecant. So how I like to do it is whenever I'm trying to graph cosecant or secant, I make a dotted line for my sine function here for cosecant. And then at the humps, I'll do solid lines because those solid lines are the actual function of cosecant. The sine function just helps us graph it. And then every time there's those x-intercepts from the sine function, there's vertical asymptotes there. And then same thing for secant. We'll draw that dotted line for cosine. And then at the humps, you draw solid lines. And then this one is a little bit more clear that at those x-intercepts, you have those vertical asymptotes going through. So the vertical asymptotes and the solid lines, those are the actual graphs of the function. Okay, so now going on to graphing these. So let's do an example of tangent. So first, we're still going to use our properties, and first we're going to start with finding the amplitude. And with tangent and cotangent, these go up and down forever. So we can still find the amplitude, but it doesn't really matter because the graphs go up and down forever anyway. So A is the amplitude is the absolute value of A. So the absolute value of 2 equals 2. So here our amplitude is 2. And then we want to find the period. And to find the period for tangent or cotangent, it's now pi divided by W. So pi divided by W gets us the period of tangent or cotangent. So W in this case is 1. So pi divided by 1 equals pi. So our period is pi on this graph. Next, we have a vertical shift of -1. So our B value equals -1. Vertical shift, we're going to shift this down 1. So let's put it all together. So I'm going to do a graph right here. Let's just put it down some more. I'll put it in this. Okay, we'll label this 0. And then there was no change in the period. So I'm just going to label like up above with tangent the pi over 2, pi, 3 pi over 2, and 2 pi. So pi over 2, pi, 3 pi over 2, and 2 pi, because the period did not change at all, and I just need to add some values on this graph. So negative pi over 2, negative pi. Okay, and then we have that vertical shift of down 1. So instead of this, if we look back at tangent, it goes through, erase this, the tangent graph goes through the origin at 0. So now it's going to go down 1, -1, and now go through that -1. So let's look up at tangent again. We have those vertical asymptotes at pi over 2. So I'm going to draw those in because this stayed the same because the period did not change. The only thing that changed really was that vertical shift. So at all my pi's over 2's. And then I'm going to draw my graph, but now going through -1. So I'm going to draw just a dotted line at that -1 so I can repeat it for my other spots. And then I'm just going to draw it one more time. Okay. And that's it. Okay. So now let's look at the cosecant graph. Let's try this one out. So we do want to look at this period change. There's no period change. I'm at the amplitude. So the amplitude is the absolute value of 2, which equals 2. And then there's that vertical shift of -1. And I like to just graph it in steps. So the final graph is the actual graph. But I like to do it in steps instead of trying to graph it all at once. So let's do the vertical shift first. And there was no period change, and the period of cosecant is 2 pi. So we're going to start at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we have that vertical shift of down -1. So I'm going to label this -1 and do our dotted line. And then just graph our sine function. So our sine starts usually at 0 and goes up 1. So now we're starting at -1, going up 1, down 1. So it's really going to -2. And then let me shrink the other graph so we don't get these mixed up together. Oops. Why does it do that? Okay, let me try one more time. Okay. That's better. Just leave it there. Okay, so now we are going up. Where we usually, when we draw sine, we go up 1 and then down to -1 and then back. But now if we're going up 1, we're really starting at -1. So we go up, down. Now we're really going to -2 and up to 2 pi. So we have that vertical shift going down 1. So our original, I'll draw the original sine graph in pink. So here's our original sine graph. And then the black graph is that shifted down 1. Okay. So now I want to take care of the amplitude. So I'm going to redraw my graph. I'll do the pink again. The pink will now be with the vertical shift. So let me plot our points. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we need -1 and -2. And then our pink graph there we go. And then we have now a amplitude change, and so the amplitude is by 2. So we just need to make this 2 more units up and down. And so if it was 2 more units up, we'd go from -1, 0, 1. And then 2 more units down, our lowest is -2. So we need to go -3 and then -4. And then our highest was 0. So we also have to go up 2 more. So -1. 0, 1, 2. Okay. So now I'll draw the final graph in black of the sine function. And remember, this is sine. So we are going to go up. That's more straight than curved. We're going to go up to 2, down to 4, up. And then remember, this is only graphing the sine function. So we need to go and add the humps. So we're going to graph that final sine function again. So we need to have -1, -2, -3, -4, and then 1, 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then I'm going to do a dotted line. And so start at -1, do our dotted line. and then up to 1. Okay. So now we have to draw the humps at the U's at our humps. So I'm going to put those, I'll just still say in black. U's. And then in between those U's, you add your vertical asymptote. So our vertical asymptote and our U's is our final graph after all the transformations for y equals 2 cosecant x minus 1.